Solve the equation 2 cosine squared of theta plus sine of theta equals 1. This equation has two distinct trigonometric expressions, cosine and sine. We will need to consolidate them so that there is only one trigonometric function showed up in the equation. Using the Pythagorean theorem, where cosine squared of theta plus sine squared of theta equals 1, we have cosine squared of theta equals 1 minus sine squared of theta, and so we will substitute cosine squared of theta with 1 minus sine squared of theta, and we rewrite everything. We distribute the 2 to get 2 minus 2 sine squared of theta plus sine of theta equals 1, and we recognize that this is a quadratic equation, so we will let t be sine of theta. Then t squared equals sine squared of theta, and this equation is now 2 minus 2t squared plus t equals 1. To solve this equation, we will need to zero it out by moving everything to the left-hand side. Subtract 1 from both sides of the equation to get 1 minus 2t squared plus t equals 0, or 2t squared minus t minus 1 equals 0. We will solve this by factoring. This is 2t times and then t times equals 0. The product of the constant terms is negative 1, and so we will try negative 1 and positive 1 to see what happens. We still need to check this though. 2t times t is 2t squared. 2t times 1 is positive 2t. Negative 1 times t is negative t. 2t minus t is positive t, not negative t. And so we will try to switch the sign to see what happens. This time we will use a plus here and the minus there. Check this again. We have 2t squared minus 2t plus 1t, which is negative 1t. And so we finally factor this correctly. This is the zero product, and so each of the factor needs to be 0. t minus 1 equals 0 and 2t plus 1 equals 0. t equals negative 1/2, t equals 1. These are not the solutions because we're looking for theta, not t. But remember that we let t be sine theta, so we substitute t back with sine theta. Sine of theta equals negative 1/2 only when theta equals 7 pi over 6 and 11 pi over 6. This is 6 pi over 6, another pi over 6 is 7 pi over 6. 2 pi is 12 pi over 6, but we have not reached 2 pi yet. We're only 1 pi over 6 away, so that is 11 pi over 6. When t equals 1, we replace the t with sine of theta and set it equal to 1. But sine of theta equals to 1 only when theta equals pi over 2. These are the principal solutions in the interval 0 to 2 pi. The general solutions are therefore 7 pi over 6 plus 2k pi. Theta equals 11 pi over 6 plus 2k pi. And the reason why we're adding 2k pi is because sine has a period of 2 pi. And theta equals pi over 2 plus 2k pi. K is an integer, 0, plus or minus 1, plus or minus 2, and so on. If we want more solutions, we set k equals 1, k equals 2, k equals 3, k equals negative 1, and so on. But when k equals 0, we obtain, again, the principal solutions.